عشان يعني لو انا محتاج حاجات comprehensive فاقدر
اوكي طيب يبقى احنا المرة اللي فاتت اتكلمنا عن ال resting membrane potential أو the resting state of the cell membrane. So this is what we call the resting membrane potential. وقلنا إنه the overall charge outside is positive and the overall charge inside is negative. وفي الحالة دي بنقول إنه the membrane is polarized or the membrane is in a state of polarization. And then upon exposure of this cardiac muscle to a stimulus, for example, a motor order or an electric impulse coming from the brain, for example, an electric impulse, then there will be the opposite. There will be a state of depolarization. This is the part you missed, يا عمرو. Depolarization معناها إنه the overall potential outside will be negative and the overall charge inside will be positive. And we said last time that the resting membrane potential is between 70 and 80, and that we put millivolts, of course, and that we put a negative sign before it in order to tell you that the inside of the membrane is negative. Here we will start by the diagram to the right, and the diagram to the right represents the action potential or the changes. The action potential is the changes in potential difference, the changes in potential difference across the cell membrane. Because we are not only talking about, in this graph, we are not only talking about depolarization, but we are also representing repolarization. So the graph represents both. It represents depolarization and then followed by repolarization. And then another stage, but these two together, depolarization and repolarization, represent the action potential. And that's why we say that the definition of the action potential, the action potential represents the changes that occur in potential difference across the cell membrane. And when we say across the cell membrane, we mean the difference between the inside of the membrane and the outside of the membrane. So every time you talk about the potential difference, then there should be a difference between two sides. And here we are talking about the difference in potential between the inside of the cell and the outside of the cell. So this is action potential. It is a diagram that represents the changes in potential difference across the cell membrane. And in this diagram, to the right, it represents the action potential in, this is very important, in any muscle cell except the cardiac muscle cell, except the cardiac muscle cell. What does this indicate? It indicates that the cardiac muscle cell has its own shape of the action potential that differs from other action potentials of all muscles. For all muscles, we start by minus 70 millivolt. Minus 70 millivolt is the resting membrane potential, the resting membrane potential. This is the, what do we mean by resting membrane potential? It is the potential difference across the cell membrane of the muscle, of course, potential difference across the cell membrane at rest. And at rest means that the cardiac muscle is not stimulated. The cardiac muscle did not receive an electric impulse or a motor order to contract. When we say 70 millivolts, this means that the outside is more positive by 70 charges than the inside. Why did we say this? Because of this negative sign. The negative sign here always refers to the inside. And then when an electric impulse comes, depolarization occurs. And when depolarization occurs, the reversal occurs, meaning that we ascend from minus 70 millivolts until we reach that level, which is 30 millivolts plus 30 millivolts. So this indicates that during depolarization, there is reversal of polarity, meaning that now the inside becomes positive and the outside becomes negative. So again, during depolarization, we moved from minus 70 millivolts to plus 30 millivolts, meaning that during this depolarization, this part of the graph where we ascend like this, during depolarization, there is what? There is reversal of polarity. How do we know that there is reversal of polarity? Because the potential difference was minus 70 millivolt and it has been converted into plus 30 millivolt. Where is the reversal of polarity here? The minus has been converted into a plus, meaning that, and since this sign minus or plus refers to the inside, then the inside now is more positive to the outside. And this is what we drew on the diagram. Yes, Amr.
I have another question. دلوقتي يعني احنا هنا we have ان the A is for myocardial cell
Yes.
and B is for or the one next to it is for any muscle cell.
Yes, other than the cardiac muscle cell. Yes, there is a difference in shape, and we're going to study or try to detect what differences we have and how this serves the function of the cardiac muscle.
Okay, أنا بس يعني I understand الكونت بس the main idea how what is the action potential يعني what does this mean كده physically?
The action potential represents the changes. We said it at the beginning, it represents the changes that occur in the potential difference across the cell membrane of the cardiac muscle fiber when it receives an electric impulse. Meaning that at the beginning, look at the diagram again, Yam. At the beginning, when the muscle fiber was resting, it was polarized. The outside was positive and the inside was negative. You're not looking at the screen, Yamr.
I'm writing the notes.
I told you to look at the diagram to understand. So
Yeah,
the outside is positive, whereas the inside is negative. And then after having received the electric impulse, reversal of polarity occurs. You were supposed to watch the first part of the video, يا عمرو, لأنه this is the part you missed. How come that you're going to follow with us if you didn't watch the first part of the video on which we are basing all the explanation today? Yani to me, it's very weird بصراحة. Depolarization means that the outside becomes negative and the inside is positive. So what happens is that, Yasin, لو سمحت, turn off the other. So what happened here is a reversal of polarity. So there has been a change in the potential difference across the cell membrane. Did you notice the change? At the beginning, we had the outside positive, the inside negative, and then the outside negative and the inside positive. So this drawing you have is a record of what happens, of the changes that occur in electric potential across the cell membrane. So we started here by the resting membrane potential, which is this part, and we ended here at the apex by being depolarized. So we are trying to draw or to represent the changes that occur in electric potential. This is the action potential. The action potential, again, is the representation of the changes that occur in the potential difference across the ياسين مش معمول هعمل لك admission كل half a second يعني كل نص ثانية بيطلع لي admit ياسين. Why?
He has internet connection issues.
طب isn't he with you in the room?
Yes, he is with us, but sometimes the phone is weaker than the laptop in internet connectivity.
طيب it's okay. Did you get it يا عمرو ولا لسه؟
Yes, أنا كده أجاوب.
طيب دلوقتي ايه السبب في انه يحصل الريفرسال اوف بولاريتي دي؟ ايه السبب في ان انا كنت الاول ماينس 70 ملي فولت وكنت بولارايزد وبعدين حصل العكس بقيت بلس 30 ملي فولت؟ السبب opening of the sodium channels. لما يكون عندي الممبرين polarized بالمنظر ده في resting state وبعدين يتفتح صوديوم channel ويدخل الصوديوم كده. طبعا the entry of sodium inside the cell will reverse the polarity. It will make the inside, it will add to the positive charge here and diminish the positive charge outside. وده سبب ان انا بتحول من polarized resting state depolarized state. opening of the sodium channel. في الأول أول ما الستيمولوس بيوصل بتتفتح شوية sodium channel صغيرين، لكن لما يحصل شوية depolarization صغيرة يبتدي يحصل magnification بقى. more and more sodium channels open وبالتالي more and more sodium enters وبالتالي نوصل للستيتس ده إنه the inside becomes positive. نوصل لعكس ما ابتدينا اللي هو reversal of polarity. بعد كده طبعا ليه بتقفل بعد كده دي قصة ياخدوها في الليفلز الأعلى من البيولوجي. بعد كده الصوديوم channels close ويبتدي channels تانية تفتح اللي هي البوتاسيوم channels. بتعمل ايه البوتاسيوم channels؟ لما بتفتح البوتاسيوم channels بتخلي البوتاسيوم يطلع لبره، يبقى أنا برجع أقلل البوزيتيفيتي inside. So when the potassium channels open بيعملوا عكس الصوديوم. الصوديوم لما كانت الصوديوم channels بتفتح الصوديوم كان بيدخل لجوه فزود لي البوزيتيفيتي inside وقلل لي البوزيتيفيتي outside وعمل لي depolarization. لكن لما البوتاسيوم channels بتفتح بعد الصوديوم channels ما بتقفل البوتاسيوم channels allow potassium to pass outwards. When it passes outwards هيرجعني تاني لأصلي، هيخلي البوزيتيف يزيد تاني outside. The positive charge will increase outside and will diminish inside and we will return again to the polarized state. وبالتالي بنسمي this repolarization. So repolarization is mainly due to opening of the potassium channels, movement of the potassium channels outwards and therefore return to the polarized state. بس طبعا احنا رجعنا للpolarized state لكن كل حاجة متلخبطة لأن دلوقتي حصل العكس. sodium is now inside and potassium is now outside. بعد كده بقى الصوديوم potassium pump will make up for this بس احنا مش هناخد الكلام دوت. خلينا نفتح سكرين كده علشان نقول انه نتكلم عن the main components of an action potential. So here, an action potential consists of two main phases, or actually three main phases. Number one, we have الأول طبعا the action resting membrane potential is not part of the action potential. بس إحنا هنكتبها بس علشان نعرف إن إحنا at the beginning we have resting membrane potential. And then we have a state of depolarization, and then we have a state of repolarization. تمام؟ resting membrane potential اللي احنا عارفين انه the outside is positive, the overall charge, while inside is negative, and we represent it as minus 70 millivolts. So احنا عارفين ان the action potential consists only of depolarization and repolarization مش داخل فيها resting membrane potential. في depolarization اللي بيحصل is exactly the opposite. بيبقى عندي the outside becomes negative and the inside becomes positive. That's why we call this reversal of polarity. Reversal of polarity. تمام؟ بعد كده بيحصل repolarization يعني هرجع لأصلي تاني، هرجع برا positive وجوه negative. يعني معنى كده إنه we can define repolarization as being return to the resting polarized state. Return to the resting polarized state. طيب مين السبب في depolarization؟ السبب في depolarization هو opening of the sodium channels. يبقى السبب في depolarization هو opening of the sodium channels, thus allowing sodium in. Opening of the sodium channels, allowing sodium in. والسبب في repolarization هو opening of the potassium channels, opening of the potassium channels, allowing potassium out, allowing potassium out. This is a brief summary of what we have said concerning the action potential, which is the representation of the changes in the electric potential across the cardiac muscle or any muscle fiber when stimulated. Now, what's the main difference between the action potential in a normal, regular cardiac muscle, in a regular muscle fiber, So this is a regular muscle, and this is a cardiac muscle cell, a cardiac muscle cell. Now ignore the green curve now. Ignore the green curve now. We will be talking about it later on, but focus on the blue curve or the blue graph that shows you the action potential of a cardiac muscle fiber. What's the difference? What major difference you can at once discover between the action potential representation of the myocardial cell and that of a regular cell?
We can see that the cardiac cell, the graph is more curved, which means it's moving and less spikes. It's moving smoother than the changes in the regular muscle cell. It's rapid.
Okay, there is a difference in shape. It's less spiky. The most significant thing you said that it is a less spiky curve. But how can you translate it more accurately? What in the action potential representation of the cardiac muscle is not present in the action potential representation of a regular muscle? Focus on the blue curve, please.
Yes, I'm looking to a plateau.
Yes, very good. We have here the plateau. How can you define a plateau?
It's when the movement of the graph starts to getting lower, very minimal movement or very minimal change.
We don't say it like this. A plateau, in terms of x and y's, we can say that however x changes, y is rather constant. So you have a rather constant value for y. So when we talk about a plateau in a graph, so if you want to define it accurately, then this simply means that it is a part of the graph where however the x values change, the y values are rather constant. Okay? This means what? This means that the process, which process, Amr, do you think is slower in the cardiac muscle than in the regular muscles? Depolarization or repolarization?
Repolarization.
Of course, repolarization, because it is that part, it is that descending part that is slower in case of, look here, this is deep repolarization starts here and we descend like this, but we don't descend abruptly like it occurs in regular muscle cells. We just have a plateau first to lengthen the duration of repolarization. Why is this important? Because of what you see on the graph. What you see on the graph is a very important term, which is the absolute refractory period. Refractory means non-responsive, and absolute means non-responsive, however strong the stimulus that is applied to the cardiac muscle. So the absolute, what is the absolute refractory period? It is the period of time, when the cardiac muscle cell when the cardiac muscle cell is absolutely irresponsive. Absolutely irresponsive. Irresponsive with a double R means non-responsive. And in order to further explain what absolutely means, we will add it is absolutely irresponsive, however strong the stimulus that is applied. However strong, so it doesn't make any difference whether the stimulus, however strong the stimulus that's applied. Okay, so it doesn't make any difference. I am irresponsive, I'll not respond whether the stimulus is a weak stimulus or is a strong stimulus. Do you think that this is important for adequate cardiac function, this longer refractory period? Of course, in the regular muscle fibers, we have an absolute refractory period, but it is much shorter than in the cardiac muscle fiber. What's the importance of having a longer absolute refractory period and a plateau in the action potential of a cardiac muscle? It prevents what? فين ياسين؟
حاجة لها علاقة بالشانلز.
And I just want you to participate.
ايوه ما انا I do participate بس من بعيد.
أنا مش سامعة. طيب أنا I'm asking you